Welcome back to my channel Conquer the Fear. In this video we are going to discuss about the drawbacks of Saga design pattern which are used in the microservices. Okay, so in previous two videos I have actually explained what is orchestration, what is choreography, but in this video I am going to explain the drawbacks of when not to use and what are the disadvantages or uh, what are the fallbacks of this, right? So it is a must watch for the people who are attending interviews and also the freshers or experienced who are preparing themselves for an interview. Okay, so there are some challenges and the limitation which I will explain. So there are around 9 to 10 of them which I will explain one by one. Please watch this video till the end. Now Saga design pattern is, we already discussed, it is going to be a way where we have to maintain the consistency between the distributed application services. Now Saga pattern, as I already told, it's one of the best solution for maintaining the data consistency when you are dealing with the distributed microservices. Now this comes with without using the 2PC, that is distributed transaction. Now there is also it will not be without any drawback, right? There will be definitely some drawbacks which is coming if we are using the Saga design pattern. Of course there are many advantages which we already discussed about our choreography and our orchestration video. Please watch that video for more information. Now let's look into the drawbacks and the limitations. Now when the first thing is about the complexity in orchestration and compensation logic. Now problem here is that, let's say you you have to define a or you must define a compensating transaction for every step that is going to fail. Okay, so let's say there are 10 transactions which you are going to initiate. Out of that, one of them has failed. Now you have to initiate a compensating transaction for that, and then you have to deal with that. You have to handle that particular logic. Okay, so logic to undo this particular previous stage is very hard to get it right, especially if you are using a real world, let's say some side effect occur. Let's say shipment has been already delivered, example, by the courier person. So there is a system which is already there. Now you cannot there is nothing which we can actually do that, but once it is delivered, right, of course we have to do some other things, like you have to recollect that, and then you have to take that order, but that's again the different story and different task. Okay, so let's say just for an example I'll give you. If you want to cancel an order after certain payment has been done, now the inventory reservation, you must have to take care of the refund of the money. You have to release that particular inventory. Okay, so there is lot of work, background work you need to do, right? So even let's say in the consecutive steps, let's say from out of 5 steps, let's say the fifth step is failing. Now you have to revert all those 4 steps which has been performed. Okay, so compensation are not just an opposite action, they are much more complex because they have there some external factors to be need to be taken care. Okay, so the result is higher development effort and the testing effort is very high. So that is what the impact of this particular complexity. Now there is also a risk of inconsistency state if the compensation fails in. So you have to always look for the consistency between the system. So every other system should have maintained the same data, whatever. If there is successful, if it is failure, the data should be consistent. The second thing is distributed state management is hard. Now when you are trying to track the state of Saga across the multiple services, let's say you have 5 to 6 services, so you are either using a centralized orchestrator or you are using an event driven state management, so which is choreography type. Now but if orchestration state it lost, okay, let's say in somewhere the orchestration, the state is lost. Now there is going to be a crash, right? So resuming the Saga can be very tricky in this particular case. Okay, so what will happen is that you often need to check the state of that particular machine, or you need to store some Saga that Saga related details, which will add one level of complexity again on top of that. Now debugging and restarting the partial completed Saga is very difficult. Okay, so it's complex over there. Longer execution time. Now what happens is that, let's say, unlike the asset transaction where the sagas are eventually consistent, not very strongly consistent, but yeah, it is consistent. Now each service has to process some event, it has to do some request synchronously over there, right? Now let's say you have a payment which has succeeded, okay? The inventory reserve items, but the shipping item takes minutes to process, okay? So until the order is in the limbo, you cannot do anything, right? So what happens? The maybe that is acceptable in some time sensitive. I mean, it is not acceptable, right, in the time sensitive systems. So it require very careful communication to the user. So order is being processed. You should be have a clear state of that. Okay. So this is one of the complexity, the longer execution time. Now, compensating transactions are not always possible in every situation. Now, that cannot be then can be undone, right? Let's say you have already sent an email, so you cannot unsend that email because it is already opened and it is already been read over there. Let's say if you have a shipment which was physically handed over to the courier and reversing is not under control right now because it is already left out, right? So this might have an incomplete transact compensation lead to a data corruption, or there is some you have to do the manual intervention over there, so which is going to require a careful business design to handle this particular irreversibility. Okay. Now increase the code coupling in orchestration. Now in orchestration knows all the steps and the services which are required to be invoked. Okay. So changes in this particular service contract will again need to change this particular contract orchestrator, right? So what happens, there is also a reduced flexibility also in this case, and also there are some autonomy from the microservices, right? So this is how the difficult the situation can be when there is some change in the service. Now it is going to be harder, right, when you are trying to evolve your services independently and you doesn't want to violate some microservices principle, right? And also other services who are using it should be able to have minimal impact. So that's what the thing is about. Now testing is quite difficult. Now testing the full saga involves coordinating with multiple services. Their state should be take a track down. The compensation transaction has to be issued up. So there is lot of effort in this. Okay. So challenges like unit testing is quite difficult. Like each component you need to validate the full saga, right? So you cannot validate that particular thing in the full saga way, right? Now integration testing also require all the services to be run together, all the states should be properly done. So it is very hard to simulate the, let's say some failure has happened, the partial failure. So it is very hard to simulate that also. And there is also some network delay which might happen between due to some issue with your network and other things. Now what happens, the test coverage is very hard to achieve in this particular case, and you need to put much more efforts and the efforts from the developer as well. Now bugs may introduce in the production, so there is always unknown things which it might introduce because the saga it might produce different, in different situation it might produce different result. Now reduce performance when you have a load, right? Let's say the saga is involving multiple network hops, right, between the services. Example, let's say you are using orchestrator and the services, right? Now compensating transaction introduced, you will have some additional processing which needs to be done. You may increase the load between the network, between the services. So there is a latency is going to increase, not going to reduce, right? It is ultimately going to reduce, increase it. Now there is also, we have to make use of the retry mechanism. So you have to add some traffic inside that. So that is going to increase the load over there. Now error handling is harder than it seems, right? Now what happens if a compensating transaction also fails? So first transaction what you already tried failed. Second, there is also a compensating transaction you have written that also fails. Now, or let's say there is a timeout. What if like the event has arrived after some it has arrived after at a very late, right? If it is not in particular order when it is required. So if let's say an example, if the shipping is cancelled, like the fails, right? If the shipping cancellation is failed, what happens? The inventory is already released now. The system would be in consistent state. Now you have to have a compensating transaction to make it consistent, right? And you have to track down all that particular state. So what happens? You need to have a fallback logic written over there. You need to check the dead letter queues. You need to have a human in the loop to check those all the particular things are working properly or not. You have a proper error handling mechanism to be introduced. You have to constantly monitor that things. You have to add a, there is a lot of overhead introduced. There is a partial failure also that can create a business logic challenge, right? Now what happens, like the unlike the atomic transaction what we do, Saga is going to have some steps which is going to succeed while others are going to fail, right? So there will be definitely some steps which will be succeeding, and definitely there will be some steps which will be failing. So let's say payment is completed. Now what happens? The inventory is resolved, but the shipping has failed due to some other reason. Let's say is not there, or there is a network failure. So how you can explain to that particular customer like who is looking out for that order, right? He will be in a heat up mode, right? So he doesn't want to get an answer that there is some network or a technical glitch over there, but he is just concerned about his order, right? Now what happens? It requires lot of status tracking. You need to have a very user-friendly messaging system and the user interface. You should be having a constant touch with the customer. You need to have a customer support manually done to have this particular such cases, the edge cases which might arise, like you're not aware or you're not taken that into the consideration as a issue. Now there might be, apart from what else we have discussed earlier, there might be also an issue with the infrastructure, right? Saga would often require lot of reliable messaging systems. So Kafka is there, RabbitMQ is there. Now Saga state stores some details or also workflow engines. Let's say you have Camunda or Temporal, right? You can have and retry and timeout and dependency mechanism introduced, right? So what happens is that there is also a non-trivial way to set up and maintain. This is very difficult. So you may introduce multiple point of failure. Let's say you're trying to handle something, there will be definitely a failure which will be there. Now, we have discussed around 9 to 10 of them. What are the different challenges and the limitation? Now, we will discuss when to not use the Saga design pattern, whether it is choreography or whether it is orchestration. That is up to you. But still, I overall at the high level, when not to use the Saga design pattern. Now, let's say you might want to avoid using or limit the Saga when you need a very strong consistency system, right? So let's say you have a bank ledgers to be updated, okay, so which is very critical because it is about transacting the date amount, right? It has to be very accurate, it has to be consistent across everywhere. Now operation which are not very easily reversible, so such things which, let's say you're sending some email, okay, which is very critical, and it is published across millions of people, and that it is irreversible. Now you cannot do that anything on that part, right? Even if you have a compensating thing, but the impact has already been done over there, right? The system which are having the real time requirement, let's say the news are there, right? New updates are there coming, right? So it will be publishing the data on the real time. In that case, now you can use redesigning to make some operation eventually consistent as and when the system grows on, right? But let's say you can make use of the soft updates, okay, so where you can consistently keep increasing your consistency. Now you can also have when you are using this centralized processing in a single service instead of the distributed flow, in that case also you can not use it, right? So you should avoid using it. I hope this video was very helpful to you. It gave an understanding of what Saga design patterns are, what are the drawbacks, okay, and when not to use this particular Saga design pattern, whether it is orchestration or choreography. So I hope I was able to explain you in details what are the details or the limitation and the challenges. If this video was helpful, please share this video with the needy people. Also, don't forget to like, subscribe, and hit the bell icon. Thank you. Thank you for watching.